Good day, students. I am Mr. Florando, your grade 8 algebra teacher. Today, we will discuss about simplifying radicals in chapter 10, lesson number 2, that is on textbook pages 619 to 620. Materials needed: first, your textbook; second, your notebook; third, pen or any ball pen. Our objective for this class is to simplify radicals involving products and quotient. First, before we go through on how to simplify a radical expression, let's define first what is a radical expression. A radical expression is an expression that contains a square root or a radical symbol. Who can give an example of a radical expression? First, we have square root of 26 or the square root of 3xy squared. As long as it contains a radical symbol or a square root symbol, it is called a radical expression. Next, the radicand is the expression under the radical sign or the square root symbol. Example, the square root of 5ab cubed. The radicand in this radical expression is 5ab cubed. The same case in the examples of a radical expression, the radicand is inside of the radical symbol. A radical expression is said to be in the simplest form if it contains no perfect square factors other than 1. In what particular form? In the radicand. Example, the square root of 14xy is in simplest form already. Why? Because the radicand here has no perfect square factors other than 1. Another example, the square root of 20xy squared is not in the simplest form. Why is that so? Because the radicand 20 has a perfect square factor that is 4, and the y raised to 2 has a perfect square factor also. Let's consider this example. Just tell me if the radical expression is in its simplest or not. The first one, the square root of 14xy, is that in the simplified form? Yes, that is in the simplified form. Why? Because you cannot find a perfect square factor in your radicand other than. The next one, 27x cubed y, is that in the simplified form? No. Why? Because 27 has a perfect square factor that is 9, and your x cubed has a perfect square factor that is x squared. So this particular radical expression is not in the simplified form. You can simplify radical expression using multiplication and division properties of square roots. Let's state first the property of the square roots for product. The product property of square root states that the square root of AB can be written as take the square root of your A times take the square root of your B. Let's say, for example, the square root of 50. So we can derive this one as the square root of 4 times the square root of 10, because the radicand 40 has a perfect square factor that is 4. You cannot find any other perfect square factor of 40 except for 1. Another example, the square root of 12x cubed y. Okay, so we can derive this one as, find, we have a perfect square factor of 12, that is 4, a perfect square factor of x cubed, that is x squared. So we can derive this radical expression 12x cubed y equals to the square root of 4x squared, that is a perfect factor of 12x cubed y, times the square root of 3xy. Okay, let's take this example on how to simplify radicals. Before, we cited already this one as the example. We can derive the square root of 40 as the square root of 4 times the square root of 10. The square root of 4 is equal to 2 and the square root of 10. Can we still find a perfect square factor of your radicand here, which is 10, that is a perfect square, except for 1? No. So therefore, you can simplify the square root of 40 as 2 square root of 10. Another one, the square root of 12x cubed y. Okay, so we can find a perfect square factor of 12, that is 4, perfect square factor of x cubed, that is x squared. So we can write this one as the square root of 4x squared times the square root of 3xy equals 2. The square root of 4 is 2, the square root of x squared, that is x, times the square root of 3xy. The square root of 3xy is already in the simplified form, so therefore we cannot simplify this one. Another example, the square root of 200x raised to 5 y raised to 8. Can you find a perfect square factor of 200? Yes, we have 100. What is that perfect square factor of x raised to 5? That is x raised to 4. Y raised to 8? That's a perfect square factor. So therefore, you can factor out the square root of 200x raised to 5 times y raised to 8 as the square root of 100 x raised to 4 y raised to 8 times the square root of 2x already. Simplifying this one, the square root of 100 is 10. The square root of x raised to 4, that is x squared. Simply divide 4 by 2. So that could be x raised to 4. The square root of y raised to 8, that is y raised to 4. Times the square root of 2x. So 2x here is already in the simplified form of your radical expression. Notice that only the positive square roots are used in the simplification of radicals. Okay, let's have this one. How can we simplify this radical expression? Square root of 18. Can you find a factor that is a perfect factor of 18? Yes, we have square root of 9 times the square root of 2. So 9 is the largest perfect square factor of 18. So simplifying this one, that could be 3 square root of 2. Another example, the square root of 36x raised to 4, y raised to 3. Can you find a perfect square factors of your radicand? For 36, what is that perfect square factor? That is 6. Okay, so 36 is already a perfect square factor. X raised to 4 is a perfect square factor. Y cubed, we have y squared is the perfect square factor already. So you can write this expression as the square root of 36x raised to 4y squared times the square root of y. Simplifying this one, that could be the square root of 36 is 6. The square root of x raised to 4, take the half of that one, that is x squared. The square root of y raised to 2, take the half of 2, that is y raised to 1. Then multiplied by the square root of y. So that's already the simplified form. Next, what about the square root of 42 AD? Can you find a perfect square factor of 42 aside from 1? No. It is already in the simplified form. Likewise for A and D, they are not perfect square factors. So therefore, this radical expression 42AD is already in the simplified form. Okay, let's take this example on how to simplify radicals. Before, we cited already this one as the example. We can write the square root of 40 as the square root of 4 times the square root of 10. The square root of 4 is equal to 2 and the square root of 10. Can we still find a perfect square factor of your radicand here, which is 10, that is a perfect square, except for 1? No. So therefore, you can simplify the square root of 40 as 2 square root of 10. Another one, the square root of 12x cubed y. Okay, so we can find a perfect square factor of 12, that is 4, perfect square factor of x cubed, that is x squared. So we can write this one as the square root of 4x squared times the square root of 3xy equals 2. The square root of 4 is 2, the square root of x squared, that is x, times the square root of 3xy. The square root of 3xy is already in the simplified form, so therefore we cannot simplify this one. Another example, the square root of 200x raised to 5. Okay, let's take this example. Simplify 5 over 3 square root of 3. Okay, so our radical expression, the denominator has a radical expression. So therefore, this one is not yet in the simplified form. So what we're going to do here is to rationalize this one in order to eliminate or remove the radical symbols in your denominator. What is the step number 1 here? Multiply numerator and denominator by the radical in the denominator. So we will have that one as 5 over 3 square root of 3. What is the radical expression in the denominator? We have square root of 3. So simply multiply your numerator and denominator by the square root of 3 over the square root of 3. Step number 2, that could be 5 times the square root of 3, that could be 5 square root of 3, then 3 times 1, that is 3. Square root of 3 times the square root of 3, that is square root of 9. So what is the square root of 9? That is 3 times 3, you will get here 9. Question. Notice that only the positive square roots are used in the simplification of a radical. Okay? If the denominator is a binomial with a radical, example, 2 plus the square root of 5 or the square root of 5 minus the square root of 7. Then, multiply the numerator and denominator by the conjugate of your denominator. So, if your denominator is a binomial with a radical, we need to multiply your numerator and denominator by the conjugate of your denominator. So, the conjugate of 2 plus the square root of 5 is 2 minus the square root of 5. The conjugate of square root of 3 minus the square root of 7 is square root of 3 plus the square root of 7. Let's have an example for this one. If we have the square root of 2 over 5 times the square root of 7 over 4, first, what we're going to do here, multiply numerator and denominator by the conjugate of the denominator already. So we will have this one as 2. Multiply first the radicand here. 2 times 7, that is 14. 5 times 4, that is 20. So we can write this one as the square root of 14 over 20. Your radicand can be simplified. That could be, what is common? 14 and 20, common is 2. So we can simplify, that is 7 over 10. Then apply the division property of square roots. So we will have this one, simplify and reduce that one. Square root of 7 over 10 can be written as the square root of 7 over the square root of 10. This is by division property of square root. So, since the denominator has a radical, we need to rationalize this one. Multiply your numerator and denominator by the square root of 10. So, that could be equals to 7 times 10, that is square root of 70. 10 times 10, that is 100. And the square root of 100 is 10. So, can we still simplify this one? No. So, that is already in the simplified form. Another example. 2 square root of 3 over negative 6 minus the square root of 8. Take note, the denominator here is a binomial that contains radical symbol already. So what we're going to do here, we need to multiply by the conjugate of your denominator. So step number 1, what is the conjugate of the denominator here? That could be multiply by negative 6 plus the square root of 8 over negative 6 plus the square root of 8. That is equal to 2 times negative 6, that is negative 12. Simply copy the radical expression, so it would be negative 12 square root of 3 plus 2 times 1, that is 2, 3 times 8, that is square root of 24 over. In your denominator, this is just sum and difference of two terms. So the result of this one is just the square of their difference. So multiply only this one. Negative 6 times negative 6, that is 36. Minus square root of 8 times the square root of 8, that is square root of 64. And what is the square root of 64? That is 8 already. Simplify further. We will have this one, negative 12 square root of 3 plus 2. So 24 has a perfect square factor. So we can write this one as 2 square root of 4 times the square root of 6 using the product property of square roots over 36 minus 8, that is 28. That is equal to negative 12 square root of 3 plus 2 times the square root of 4, that is 2 times 2, you will get 4 square root of 6 over 28. We can further simplify this one. What is the GCF? We can divide by 2. So divide 12 by 2, that is negative 6 square root of 3 plus 2 square root of 6 over 14.